In this video, we are going to give you an introduction to reaction rates and chemical kinetics. First of all, chemical kinetics is defined as the area of chemistry that studies reaction rates. And one of the important things about studying chemical kinetics is that it allows us to determine the mechanism of a reaction or the sequence of steps by which a reaction occurs. We'll talk a little bit about that later. Kinetics is different than thermodynamics. Thermodynamics essentially tells us if a reaction will occur spontaneously or non-spontaneously. Kinetics gives us an idea of how fast a reaction will proceed. So if we're measuring reaction rates, let's say we want to measure the conversion of A into B. We can measure it two ways. We can measure the speed at which reactant A disappears, or we can measure the rate at which product B appears. We could write an equation for this, or a couple of equations, if we wanted to look at the decrease in the concentration of A, or measure the rate based on the decrease in concentration of A. We would use an equation like this, where we measure the reaction rate as a change in concentration of A over some change in time. And we have a negative sign here because the concentration of A is decreasing, and we can't have a negative rate. The rate of a reaction must always be positive, so we put a negative sign there to make it positive. So this would give us the rate of the reaction over a given time period based on the decrease in concentration of A. We could also measure the rate of a reaction based on the change in concentration of product B over some time period. So the rate would be equal to the change in concentration of B over the change in time. And here, since the concentration of B will be increasing, we don't have to put a negative sign. We would keep that as positive. If we were to graph this, the conversion of A to B, we would see if we graph it as the number of molecules or the change in concentration versus some time, we would see that the molecules or concentration of A will decrease over time, whereas the molecules or the concentration of B will increase over time. So let's take a look at an actual chemical reaction. In this chemical reaction, we are looking at the decomposition of dinitrogen pentoxide to form nitrogen dioxide plus oxygen. So here's the balanced chemical equation. If we start with some concentration of dinitrogen pentoxide and no products, you can see that over time, as the time increases, you'll see that the concentration of our reactant decreases and the concentrations of our products begin to increase, which is what we would expect. If we were to want to measure the rate of a reaction, we would have to determine what time period we want to measure the reaction rate. So let's say we wanted to measure the decomposition of dinitrogen pentoxide between 300 and 400 seconds. Okay? So that would be between here over this time period between 300 and 400 seconds. And we're measuring the decrease in concentration of our N2O5. So we would put our final concentration minus our initial concentration. This would be the concentration at 400 seconds minus the concentration at 300 seconds. And we would divide that by our change in time. Our final time, which would be 400 seconds minus 300 seconds, our initial time. And we have to make this, we have to put a negative sign here so that because our concentration of N2O5 is decreasing. If we perform the math here, you'll see that we have a rate of 1.9 times 10 to the minus 5, and the units of a reaction rate is generally expressed in molarities per second. So we have units of concentration over time. So the units of rate, and we always want to be sure to include our units, are molarities per second. Now, one other thing, if we look at this chemical reaction, we want to look at the stoichiometry. You can see that we have, in our balanced equation, 2 moles of dinitrogen pentoxide will react to form 4 moles of nitrogen dioxide and 1 mole of oxygen. And the reaction rate is related to the stoichiometry. So if you take a careful look at our graph here, you see the initial concentration of our N2O5, and of course our concentration of N2O5 is going to decrease over time. Our products, our concentration of products, NO2 and O2, those concentrations are going to increase, but they don't increase at the same rate, and that's because of the stoichiometry. For every 1 mole of oxygen that's formed, 4 moles of NO2 is formed. So looking at the slope of this line, you can see that our NO2 is formed at a rate 4 times faster than the rate of O2 formation. We can write a general expression relating all of these rates as shown here. Our concentration, our change in concentration of O2 over time is equal to 1/4 the change in concentration of NO2 over the change in time. And those are all equal to negative 1/2 the change in concentration of N2O5 over the change in time. So what this is saying, in order for these reaction rates, let's look at the rates of NO2 formation and O2 formation. In order for these to be set equal to each other, we would have to multiply the rate of NO2 formation by 1/4, since it's formed 4 times faster than the rate of formation of O2. And again, for our reactant, the rate of reactant decrease, we have to put a negative sign here because this concentration of N2O5 is going to be decreasing over time. Okay? So in general, for this, for a general equation, take a look at this and you can kind of see how we would set all of the rates equal to each other. So let's take a look at a problem where we need to examine the stoichiometry of a particular reaction. In this reaction is the conversion of glucose into ethanol and carbon dioxide. And the question asks 2 parts. How is the rate of formation of ethanol related to the rate of consumption of glucose? So how is the rate of ethanol formation related to the rate of glucose decrease in concentration? And the second part, write a relationship in terms of the change in concentration of ethanol over time and the change in glucose over time. So take a minute, pause this, and see if you can see how you would answer these questions. Okay. So let's take a look at the answer. So according to our balanced equation, you can see that the ethanol, for every 1 mole of glucose that is consumed, 2 moles of ethanol are produced. So the rate of ethanol formation is going to be twice the rate of glucose consumption. And for the second part, we need to write this in a kind of a mathematical expression, and there's a couple of ways you could do it. Here you could say we have the change in ethanol concentration over time is equal to the negative, since our glucose is decreasing, -2 times the change in concentration of glucose over change in time. So that's one way to express it. The other way you could have expressed it would be to say 1/2 times the change in concentration of ethanol over time is equal to -1 times the change in concentration of glucose over time. So it's important to appreciate how the stoichiometry of a chemical reaction relates to the reaction rates and be able to express those in a mathematical expression.